Welcome all of you. So today I am Rosalind Mishra. I will be dealing with inorganic chemistry, pharmaceutical inorganic chemistry. So in today's class, like in the previous class, we had discussed what is pharmaceutical inorganic chemistry, followed by we got into our unit 4. Alright, we had started expectorants in our previous class. In today's class, we shall continue the same topic, expectorants. Alright. Now moving on further. Before understanding what is an expectorant, it is important for us to know what is cough. Alright, because expectorant is a drug, it is a medication which induces cough or which helps in removing certain substances from our body with the help of cough. So what is cough first of all? Well, cough is a productive reflux which helps to expel irritant matter from the respiratory tract. Alright, what does a cough do? It helps to expel the irritant matter from the respiratory tract. It helps in removing out the irritant from our respiratory tract. Very simple. It could be productive or non-productive. If the sputum is released, if mucus is released, then it comes under the category of productive cough. If no sputum or mucus releases, then it is non-productive cough. Now, a question arises in our mind, how is cough related to expectorants? Why do we need to understand cough before learning expectorant? Well, for that, we need to understand what are expectorants. Expectorants are drugs that help in removing the sputum from the respiratory tract. Alright, they help in removing the sputum from the respiratory tract. How do they remove the sputum? By two mechanisms, by two methods. Either by increasing the fluidity, and increasing fluidity and thereby decreasing viscosity of mucus or the sputum, Alright. Otherwise, the second mechanism which comes into picture is increasing the volume of the fluid that has to be expelled from the respiratory tract. So how does an expectorant work? It either increases the fluidity of the sputum, thereby decreasing the viscosity, or by increasing the volume of the fluid, which is to be expelled out. Now, again looking into detail about expectorants. Expectorants are medications or natural ingredients that help clear mucus from the airway. What does expectorant do? These are natural ingredients or synthetically derived or semi-synthetically derived substances, pharmaceutical ingredients that help in removing out mucus from the respiratory tract or from the airways. Next, they are used in the treatment of various cough. Which typically occur with cold. Alright. See, cough happens either due to cold or due to certain irritant if it is present in our airways. Okay, there could be any reason for cough, but an expectorant can be used in case of cold, due to which the mucus gets viscous and sticky. Hence, an expectorant is used where the sputum or the mucus or the phlegm could be made less viscous or more fluid. Hence, it can be removed out. So, expectorants are medications or natural ingredients that help to clear mucus from the airways. They are used in the treatment of various cough which typically occur with cold. Alright, as I have just explained, for those cough which occur due to cold, expectorants are used. Examples of inorganic expectorants are ammonium chloride, potassium iodide, ammonium chloride, potassium iodide, sodium iodide and related substance. Now moving on further, how do we classify expectorants? The second question which comes into picture is, what are the types of expectorants and how are they classified? What are the types of expectorants and how do we classify these expectorants? Well, expectorants are classified into two major categories. Number one, sedative expectorant. Number one being sedative expectorant and number two, stimulant expectorant. Sedative expectorant and stimulant expectorant. How do these two types of expectorant differ from each other? See, one of these expectorants act on the gastric reflux, whereas the second category or the second variety of expectorant act on the respiratory tract. They act on stimulating the respiratory tract, which is what we will learn in our later slides. Sedative expectorant, example ammonium chloride and potassium iodide, whereas stimulant expectorant, the category which falls under stimulant expectorants are the naturally deriving expectorants. Naturally derived expectorants, which is eucalyptus and lemon. So moving on further, now we will be discussing about sedative expectorants in detail. Alright, so we will be discussing about sedative expectorants in detail. See, sedative expectorants, they act on the gastric reflux. Alright, they act on the gastric reflux. These are stomach irritant expectorants. What are sedative expectorants? They are stomach irritant expectorants, which are able to produce their effect through stimulating the gastric reflexes. Alright, how does sedative expectorant show their activity? By stimulating the gastric reflexes. For example, bitter drugs, ipecac, senega, Indian squill. So these are the few examples of sedative expectorants. We will discuss again what is a sedative expectorant. They act on gastric reflux. First thing which we need to remember about sedative expectorant is they act on the gastric reflex. How do they act? What do they do? They are stomach irritant expectorants which are able to produce their effect through stimulating the gastric reflexes. Clear all of you? Now, these sedative expectorants belong to two major categories. Number one, naturally derived compounds. Number two, inorganic compounds. Number one, naturally derived compounds. Number two, inorganic compounds. What are the naturally derived compounds? Bitter drug, ipecac, senega and Indian squill. Whereas the inorganic compounds can be briefed as antimony potassium tartarate. These are inorganic expectorants which act on the gastric refluxes. They stimulate the gastric reflux. They are stomach irritants. Alright. So antimony potassium tartarate followed by ammonium chloride, sodium citrate and potassium iodide. Clear all of you? So this is about sedative expectorant. Now moving on further, we will look into stimulant expectorant. Now what is the stimulant expectorant? How does the stimulant expectorant act? Well, these are the expectorants which bring about a stimulation of the secretory cells of the respiratory tract. What does a stimulant expectorant do? They stimulate the secretory cells of the respiratory tract. Alright, so this is what we are to remember. Sedative expectorants, where did they act? Sedative expectorants act at gastric reflux. They stimulate the gastric refluxes. Whereas stimulant expectorants, where do they act? They act on the respiratory tract, or they stimulate the secretory cells of the respiratory tract, either directly or indirectly. Since these drugs stimulate secretion, more fluid in respiratory tract and the sputum is diluted. Alright, so what is the mechanism of action of a stimulant expectorant? Well, how do they decrease the viscosity or how do they increase the fluidity of the mucus in the respiratory tract? By increasing the volume of the fluid. Clear all of you? How did a stimulant expectorant act? By increasing the fluidity or by increasing the volume of the fluid inside the respiratory tract. Since the volume is increased, since the volume of the fluid or the sputum is increased, hence it gets diluted. Hence it gets diluted. Clear all of you? So how does a stimulant expectorant work? A stimulant expectorant stimulates the secretory cells of the respiratory tract. Secretory cells of the respiratory tract. Since the secretory cells are activated, more fluid is produced. Increased fluid is produced. This increase in volume of the fluid helps in diluting the sputum. It helps in diluting the sputum. Hence, it can be easily removed out. Clear all of you? The major difference between sedative expectorant and stimulant expectorant. What does the stimulant expectorant do? They activate the secretory cells or they stimulate the secretory cells to secrete more fluid. Hence, dilution of the sputum happens. Hence, it can be expelled or expelled out easily. Example, eucalyptus, lemon and anise. These are the examples of naturally occurring stimulant expectorants. Now, moving on further, what are the phytosources? What are the plant sources for expectorants? Well, the plant sources, or to be more precise, the phytosources for the expectorants can be categorized as follows. Botanical expectorants act to increase the quantity, decrease the viscosity and promote the expulsion of the secretion of the respiratory mucous membrane. Clear all of you? What does a botanical expectorant do? Botanical expectorant, for example, eucalyptus, lemon, anise. Other examples, ipecac, senega, Indian squill. These are all phytosources for expectorants. Apart from inorganic sources, the ones which I have just briefed down are the phytosources of expectorants. These are the phytosources of expectorants. Alright. So, what does these botanical preparations do? What does this botanical expectorants do? They increase the quantity, they increase the quantity, they decrease the viscosity, and promote the expulsion या removal. They help in the removal or they promote the expulsion of the secretions of the respiratory mucous membranes. Alright. Many also have, most of these phytosources or most of these phytoexpectorants also have antibacterial and antiviral activity. That is, they help in the removal or they help in the expulsion of bacteria and virus as well, or they also act as an antibacterial and antiviral agent. Some expectorants are also antitussives. Some expectorants are also antitussives, that is, they stimulate cough. However, Lobelia inflata, a commonly used expectorant, promotes the cough reflex. Clear, all of you? See, till now what we had learnt was our expectorants, they did not act on the cough refluxes. They acted on the mucous membrane, hence increasing the secretion, or they acted on the gastric reflux. But there are certain expectorants which promote cough reflux as well. For example, Lobelia. Lobelia may be more effective at clearing the lungs. Lobelia may be more effective at clearing the lungs than other expectorants. Alright, when the cough is productive, because first of all, it acts on the viscosity and fluidity of the sputum, and also it stimulates cough. Other commonly used expectorants include Glycyrrhiza glabra, also known as licorice, Pelargonium xydioides, which is also known as South African geranium. Next, we have Hedera helix, also known as ivy, and wild cherry bark. These are the botanical expectorants. Now, moving on further, we will be discussing about example of expectorant which has been mentioned in your syllabus. Alright, your syllabus expects us to understand two major expectorants, which is potassium iodide and ammonium chloride. Potassium iodide we had discussed in our previous class already. Now we will be discussing, or now we will be looking into ammonium chloride. Alright. Now the molecular formula of ammonium chloride, NH4Cl, it has a molecular weight of 53.49 grams per mole. It is also known as sal ammoniac. This is how ammonium chloride crystals look like. Ammonium chloride has a tetrahedral structure with ammonia in the center, and it is attached to chloride molecules. Now, we will be looking into details about preparation of ammonium chloride. Alright. Number 1, the first method for preparation of ammonium chloride is using ammonia. Okay. So, ammonia is neutralized. Ammonia is a base. Okay. So, neutralization of ammonia with an acid, hydrochloric acid, with a strong acid or hydrochloric acid, produces ammonium chloride, produces NH4Cl or ammonium chloride. The solution is evaporated till crude crystalline mass of ammonium chloride is obtained. Something like this. Crystalline mass of ammonium chloride is obtained. Another method for the preparation of ammonium chloride is heat the ammonium sulfate with sodium chloride. Heating ammonium sulfate, NH4 twice SO4, ammonium sulfate with sodium chloride leads to formation of ammonium chloride. Via two steps. In step number 1, ammonia is released. In step number 1, it is a two-step reaction. Step number 1, ammonia is released out, that is NH3. In the next step, or step number 2, this ammonia has to be neutralized with hydrochloric acid. Again, neutralized with hydrochloric acid. That is, it is a strong acid. So, it produces NH4Cl. Properties. These are white, fine crystalline or coarse crystalline powder, odorless and have cooling saline taste. They are soluble in water and glycerol. The chemical property includes Ammonium chloride is a colorless crystalline substance. It is highly soluble in water, readily forms slightly acidic solution. It vaporizes without melting at 340 degrees Celsius. See, assay of ammonium chloride. How do we determine the purity of ammonium chloride? Via assay. There are two assay methods, the one involving precipitation titration, the second involving acid-base titration. We will be discussing both in today's class. Step number 1, ammonium chloride forms acidic solution when dissolved in water. Very true, it is a base. When dissolved in water, it forms an acidic solution. In aqueous solution of ammonium chloride, nitric acid, nitrobenzene and excess amount of silver nitrate is added. Nitric oxide, nitrobenzene and excess amount of silver nitrate is added and it is shaken vigorously. Okay. So, ammonium chloride is made to react with silver nitrate. It is made to react with silver nitrate. This is the basic reaction. See, silver chloride is hence precipitated out. This silver ammonium chloride is made to react with silver nitrate. In the presence of ammonium chloride is made to react with silver nitrate in the presence of nitric acid and nitrobenzene. Silver chloride is precipitated out. It is coagulated by nitrobenzene. That is why we add nitrobenzene for coagulation of silver chloride. Finally, it is titrated with standard 0.1 molar ammonium thiocyanate using ferric ammonium sulfate as indicator. Okay, so ferric ammonium sulfate is added as indicator. Is the indicator used here. Okay, so what happens? Ammonium chloride is made to react with silver nitrate solution. Silver chloride is formed. Silver chloride is formed. This precipitation is increased in the presence of nitrobenzene. Okay, next. It is again made to react with ammonium thiocyanate. It is titrated with ammonium thiocyanate. So, each ml of 0.1 molar silver nitrate is equivalent to 0.005349 grams of ammonium chloride. Clear all of you? Now, moving on further. Acid-base titration. Assay of ammonium chloride can also be done by acid-base titration. In the second method, ammonium chloride is assayed by acid-base titration method. In this titration, ammonium chloride undergoes hydrolysis to form ammonium hydroxide and hydrochloric acid. See, ammonium chloride when dissolved in water form ammonium hydroxide. This ammonium hydroxide is then made to react with our formaldehyde. See, this reaction is facilitated by the addition of formaldehyde as it fixes the ammonia by forming hexamine. Alright. So, ammonium chloride when dissolved in water, it forms ammonium hydroxide. It forms ammonium hydroxide. Alright. After that, this ammonium hydroxide is fixed with the help of formaldehyde to form hexamine. To form hexamine. Alright. The formaldehyde is added to the ammonium chloride to impart acidic property to the compound. And then it can be titrated with the standard alkali. Alright. So, first ammonium chloride is dissolved in water. It is converted into ammonium hydroxide. This is then fixed by using formaldehyde into hexamine. This acidic hexamine is then titrated with 0.1 molar sodium, 0.1 normal sodium hydroxide, which is equivalent to 0.005349 gram of ammonium chloride. Clear all of you? Now moving on further. Uses. It is used as a mild expectorant. It maintains acid-base equilibrium of the body fluid. It is stored in well closed containers. Thank you.